Hello students, welcome back to Uplift Education virtual classroom. Today we are in the science lesson. Today we are going to start a new subtopic called mechanical separation or physical separation of components from a mixture. We know we have so much of natural mixtures exist, but most of the time we need some pure elements, something like we need gold, but we know the gold is not exist in its pure state. It exists in a mixture with so much of impurities. So if you consider air, in the introduction, I think 2 videos back we discussed about the air mixture. It contains so much of different gases. Okay, so in industries like hospital, we need oxygen. So there is an importance of separation of these gases. Also, you know, crude oil. Crude oil is a mixture of so much of fossil fuel, or it's a mixture. So we have to separate it to take petrol, diesel, kerosene, and so many other factors. So this separation is an important feature to be discussed. Let us look at some mechanical separation. Let me start. What is mechanical separation? So when I say mechanical separation, there are so many different methods of separation available. Some are mechanical, some are chemicals. Okay. So in this topic, whenever we can separate a physical component from mixture in a physical method, or depend on a physical feature of the mixture, we call it as the mechanical separation. Okay, let's look at some examples. Like if you go to the paddy field after the harvesting, you know, the people use some to send a large current of air to pass through the to separate the rice and chaff. So we call it as winnowing. So another one is in the construction site. Some people the working people might need the fine only sand particle, not the harder particle. So they have some other technique to separate that. Also, you know, before cooking, the mung seeds or the green gram seeds, you know, when we soak in water, we can see the viable seeds settle at the bottom and some unviable seeds are floats on top. So before we cook, most of us used to separate these floating mung seeds. So there are different physical features available. So some are like size, some are like density, some are like shape of the particles. So as a definition for mechanical separation, we call a separation technique, okay, based on the physical features such as its shape, its size, its density, or even the nature of electric nature, magnetic nature. So if you are do the separation based on any of these features, we call this as the mechanical separation. So in physical separation, with the mechanical separation, we have different techniques. We'll start discussing one by one. We'll start our discussion with the procedure called filtration. This filtration, we all are familiar in our day-to-day life. Let's recall something happens in kitchen. All might heard about coconut milk. So what we do is we pluck the coconut and we scrap to obtain the small white color coconut scrap, and we add some water to it and we mix it, and we might see when squeezing the important thing is we need the coconut milk, not the coconut scrap. So to get the pure milk, what we do is using our hand we get the scrap and we squeeze it, getting only the coconut milk. You know, even though physically we remove most of the coconut scrap, you know, there is some part sticking on the coconut milk, but what we need is a pure coconut milk. So using a strainer, milk strainer, you might heard like it's like when even it is used when making tea. There's a strainer. We pour the coconut milk with a small amount of scrap into this. What happens is this coconut scrap gets stuck here, and only the pure coconut milk flow down and we collect it in a vessel, right? So this is something day to day that happens. So this is the simple method or the simple principle of filtration, right? Let's look at an example that we discuss or that we practice in our laboratories. Hope in our when I starting the topic mixture in our previous video, we explained about the mothball and the copper sulfate mixture. This I said mothball or the nectarine. Mothball is a white color ball and the other one is copper sulfate. You know the anhydride copper sulfate is a white color powder, right? So we crush these mothballs to white color powder. So now I have two white color powders, right? So now I take a vessel, I mix these mothball and copper sulfate powders and I keep adding water. So what happens is these mothballs or the naphthalene powders do not dissolve in water, right? But this copper sulfate dissolve in water, resulting in a blue color solution, while the mothball residues remains here. We say when giving the definition for mixture, we say we can separate these mixtures. How? Let me use this space. I am going to take this vessel and pour into another vessel. But before I am pouring the vessel, I have to keep a filter paper on top of this. So when I keep the filter paper, what happens is the mothball powders or the naphthalene powders get stuck on this my filter paper, and only the filter or only the copper sulfate solution pass into the next vessel, right? So we call this the mothball or the naphthalene that is stuck on the filter paper. We call this as the residue, and the solution that is passed into the next vessel, we call this as the filtrate, right? Let us look at a second method called vaporization or evaporation. And this is also very common and most of us already knew this. So you all might heard about solvents, solvent. So in solvent, this vaporization technique or the evaporation technique is very commonly used. So what do you mean by this vaporization or evaporation? A mixture or solid mixture that is already exists in a solution. So what we do is we evaporate the solvent and we obtain only the crystal solute, right? So we know that table salt or the sodium chloride that we commonly use at our home, we call it as table salt. We know that is taken from seawater, right? So the solvent is the place how they extract this common salt or even other laboratory salts from seawater. You know that it happens in solvent. What happens is the solvent from the sea, they take the seawater, maybe using some pipes or even some other way. What happens is they take the seawater into these pits. So in solvent, and they allow it to expose into sunlight for so long. When it exposes it for so long, the water in this part gets evaporated, right? When it evaporates, the solutes in this solution start getting saturated. Once the seawater, we consider seawater, it's rich in salts, not only sodium chloride. There are so much of salts, right? So if we keep evaporating, one by one, all the solute in the seawater will start attaining its saturation level. Once the saturation level is attained, it will start precipitating at the bottom, right? So in solvent we have three tanks like this. In the first tank, the calcium carbonate will precipitate. It is not in our syllabus, that is used for other purposes. And in the second tank, calcium sulfate will be precipitated. In the third tank, the sodium chloride will be precipitated. And after the third tank, the water may be sent back into a sea or ocean. So the idea is very simple. They are exposing it to sunlight and allowing the solvent to evaporate or vaporize, and the solution getting saturated with the particular solute, and it start forming precipitate. So this is the simple idea behind the vaporization or evaporation. Based on this idea, there are some other, based on this principle, some other separation technique also available. We call one as crystallization. The other one, second one is the recrystallization. We will look at about this crystallization and recrystallization one by one. Okay, now let us look at about decrystallization. When I say crystallization, what happens is, let's say if I have a solution and there is a solute which can be turned into solid, right? So let me say I have a solution filled with the solute that can be turned into solid. What happens is, using some evaporation technique or using heating, it may be a Bunsen burner, candle, or some other heating source. What we do is we keep on heating the solution and we make the solvent, or most of the time the solvent might be water. We allow the water to get evaporate, right? So what happens is the solution start attaining or the solute start attaining its saturation level. Saturation level is attained when maximum amount of solute at particular temperature is present. We call it as saturation. And when the solvent further get evaporated, the concentration of the solution even increases and the solute start getting precipitated at the bottom. We call this as the crystallization. A very common example we can consider sugarcane industry, where we obtain some sort of solution. We don't just get crystals from the sugarcane, right? Sugarcane or beetroot. What we do is when we pass through the machine, we get some sort of pure solution or colorless solution, right? That solution mostly contains sugar component and it has some other solvent also. So in the sugar industry, they set in certain machines and allow it to get heat, right? When they are heating, the solvent or the solvent component get evaporate and the solute, or in sugarcane industry, the sugar get precipitate at the bottom. Now let us look at about the third type, recrystallization. So when I say recrystallization, it is a simple technique that is used to purify a pure element from its impurities. Okay, so if I say as a definition, if we have a solid substance, we convert this solid substance into a solution, and again the solute is converted back to solid. That's very simple. So let's discuss this with an example. If you consider gold exists in its gold ores, right? It's not exist as its pure state. So gold exists with its impurities and it as a ores. So in making jewels and other purposes, we need pure gold. So in order to obtain the pure gold, what we do is we get the gold ore and we crush it and we mix it in a very hot gold amalgam. We call this amalgam. Amalgam is a solvent that dissolves the gold, right? So we dissolve the gold ore mixed with impurities, and only the gold dissolved in this amalgam and the impurities get stuck or that do not dissolve in this amalgam. Okay, for this purpose we use a very hot solvent, maybe at a temperature of 200 degrees Celsius, and we keep adding gold until this solution is getting saturated with gold, right? So once this solution is getting saturated with gold, we know we have a saturated solution of gold, and the impurities that is already existed in the gold ore will start floating on top, right? So using some physical separation, might be using a net or some other method, we can remove the impurities present in the gold, or that is present in the gold amalgam mixture, or even sometimes a very trace amount of impurities might get dissolved in this amalgam. So as a next procedure, what we do is we know the definition for saturation. Maximum amount of solute that can dissolve at a particular temperature. At this point, we have chosen a really higher temperature. At a higher temperature, for the same solute and same solvent, the saturation limit is really high. So what we do is we transfer this vessel into a place where the temperature is lower compared to this, or maybe to a room temperature. Let's say this is 30 degrees Celsius. The saturation limit of gold at 30 degrees Celsius is much smaller compared to 200 degrees Celsius, right? So what happens is at 30 degrees Celsius, now the concentration of the gold in the gold amalgam mixture is much more greater than the saturated level. So what happens is the gold start forming crystals or start forming precipitation. What happens to the slight amount of impurities that is already dissolved in amalgam? We know most of the impurities does not dissolve, and this slight amount of impurity might not get saturated at this point, right? So we can have only the pure gold to get precipitated, right? So we can remove gold out and we'll obtain pure gold. Okay, now let's start discussing about the solvent extraction method. So before I come into the proper definition of solvent extraction, let us look at some solubility of different solutes and different solvents. I guess we discussed about this in our starting video about the mixtures, right? So in that video we considered the solubility of sugar in water and coconut oil. We know the sugar dissolves really well in water compared to coconut oil. Similar to that, based on its polarity and non-polar, polar, non-polar, organic, inorganic, based on this factor, there is a difference in solubility. So, if you have a particular solute, let me say I have a mixture and it contains two different solvents in it. Okay. Let me keep at the middle of it a particular solute. Maybe using some other technique. Let me say I am exactly keeping on top, right? So there is a possibility of this solute getting preferred to any one of these solvents. So sometimes this might be moved down, and 95% of this solvent might get dissolved in one solvent, and 5% might dissolve in the other solvent, right? So this percentage can be varied, something like 99% bottom and 1% on top, or it can be vice versa also, right? So using this, we'll look at another example. The common example that we look at in our laboratory is the iodine solution and carbon tetrachloride. Let me consider a solution. Let me consider I have a mixture and it has two solvents. Let me say I have carbon tetrachloride CCl4 and water, or let me say aqueous iodine solution, not just water. This is aqueous iodine I have on top and I place it on carbon tetrachloride. This carbon tetrachloride is a non-polar substance and iodine too is a non-polar substance, and water is a very good polar substance. Hope you remember in our early video we discussed polar substance dissolve really well in polar substance and non-polar substance dissolve really well in non-polar substance. So what happens is, if I keep an aqueous iodine solution, or if I pour this aqueous iodine solution on top of a carbon tetrachloride, first thing the carbon tetrachloride and water will separate like water and coconut oil separately, right? So we will have two different solvents separately, which has a common interference boundary, right? So after some time, due to this iodine, we know this iodine is very dark purple. So since this is an aqueous iodine, we all can see this was very dark in color, and carbon tetrachloride is a colorless solution. If we keep this for some time, we will observe with time the color on top slightly disappear, and this becomes a pale purple, and this bottom part start getting condensed purple. The reason the iodine prefers carbon tetrachloride much more compared to the water. This is a simple technique that is used in solvent extraction. So these ideas can be used, when making medicines, we take the extract from plants. Not only medicine, even making like perfumes and some other materials, most of the thing we obtain from plants. In plants, we obtain in very small amount extraction, right? So, but in our reality, we might need in a large quantity. So, in a laboratory, what we do is, we take this small quantity and we extract only the factor that is responsible for the medicine, or the factor that is responsible for fragrance, and we separate it using a solvent, right? So, in this case, what we do is, now we can separate the water and carbon tetrachloride solution, and we take the CCl4 and iodine. Now this is a mixture carbon tetrachloride and iodine. Using a very small heat, we can quickly evaporate this carbon tetrachloride. So what we get is, we will get the pure iodine to be remain. The same technique can be used in perfume industry or in the medicine industry. So simply we say the definition for solvent extraction is extracting a factor or solute or component of a mixture from a solvent in which it is less soluble into a solvent in which it's more soluble, right? I think it's clear. Extracting a solute from a solvent in it which less soluble into a solvent in which it's more soluble, where both the solvent are immiscible and which are immiscible and shares a common boundary, right? Or considering again the efficiency of this video, we are supposed to stop our discussion at this point. We will discuss about the remaining parts in our next video. So catch you in our next video. If you have any doubts or questions, even suggestions and feedbacks, you can use the comment section.